Welcome, everyone. I'm Tapas. Been working as a data architect in MathCo with over 12 years of experience. I've joined with Mansit, who is also part of the engineering team at MathCo. So today we'll be going over architecting contextual layer and how it can be used to power next-gen AI systems, right? Now, before we go any further into context, let's first understand why there is so much buzz around AI and Gen AI specifically, right? How many here have not heard of Gen AI? Oh, there are a few unicorns here who have not heard of Gen AI, which is interesting. But contrary to unpopular belief, Gen AI is here to stay, and there are a lot of enterprises who are using Gen AI in their day-to-day operations to revolutionize their operations and also bring better actionable insights out of it, right? The numbers speak for themselves. So if you look at what Bloomberg is doing or JP Morgan is doing, we can see that there is immense potential in using these Gen AI systems, right? And we are also seeing that there is a lot of push happening from different enterprises like Microsoft or Google to make Gen AI more accessible, be it the launch of small language models or one-bit LLMs, which can run on CPUs and doesn't require any big, bulky GPUs in order to run inferences, right? So how can we make Gen AI more intelligent, right? That's where the context comes into the picture, right? Because even if you go to ChatGPT right now and you try to search that, can you give me what is my sales forecast for this year? It will not be able to give you an answer because it doesn't know what your company does, what your organization is, what your business line is. That's where context happens, right? So I'll take a small use case of something that we have solved for one of the retail customers that we worked with, right? So we were given a very simple problem statement, right? We were asked to build a personalized recommendation engine, which will be used to do personalized ads and targeted ads for their customers, right? We went through a lot of iterations of Gen AI, LLMs, and how we can make it more intelligent. But ultimately, the secret sauce to building all of this is the contextual layer, right? So we have given a small snippet of what are the different stages that we went through. So because we were dealing with customer data for retail, right? So the data is coming from so many diverse data sources, right? So there is point of sale systems, there are digital stores, physical stores, there is profile information, demographic information, right? So all of this information gets captured in the integration layer. From there, we start building the contextual layer, which is the secret sauce to this application, right? Where we start collecting the metadata about it, the vectorized embeddings, the semantic tags, or the knowledge graphs information, right? And which all of this gets stored into a storage layer where you can use vector databases, knowledge graphs, traditional data warehousing applications, feature stores, so on and so forth, right? This data eventually gets used to power the AI systems, be it the recommendation models, the customer 360 dashboards, be it the segmentation models or personalization rules that you want to use, right? And eventually how we hand it over to the business users, data analysts, the technical teams downstream, right? So that's where we built an access layer as well, be it exposing it in terms of APIs, like marketing APIs, or even analytics platforms, right? So that they can slice and dice the data, they can ask questions to it, interact in natural language, and make better decisions based on that information, right? And if you look at the numbers, we were successful in achieving that. We were able to give a richer customer experience, which resulted in 40% increase in the customer engagement, and also increased the customer lifetime value by 42%. Now, going further, if I had to break down the structure that I showed there, right? So essentially, it's three different pillars that work in harmony to build an intelligent AI system, right? So one is obviously the model itself, where you build your LLM models, you decide the hyperparameter tuning, you define the context size. Next is the engineering techniques, right? What kind of model you want to use, whether you want to do one-shot learning or few-shot learning, what kind of data formats you want to use to train your models. And the third and the most important one is the contextual data, right? Which is where we see a lot of technologies like RAGs, NLCs, user case informations coming up, right? So what does this contextual layer do, right? So if you look at any RAG-based application, what it helps us is factually making sure that the AI responses are factually correct. So it grounds that information that the AI is giving us, right? Making sure that it's relevant in terms of the context in which that question is being asked, right? But is it so easy to build this contextual layer? Now, that's where I wanted to first showcase like where all the context can come from, right? So it can come from so many different places. There is data and metadata information, which is where you capture the data asset descriptions, the column level descriptions, data classification informations, data dictionaries. Then there is the domain and subdomain level informations, org and persona level information, right? Org hierarchies. Like let's say for the same application, if a CXO level person is asking a question versus a manager is asking a question, the system should be able to understand based on the role of that person what question or what answer to give, right? Because if a manager is asking, his area may be a smaller area, whereas a CXO is looking at a much uber level compared to that, right? Then we also have business workflows. So the system should be able to understand using this context that how the response it is giving is going to help in the decision-making process, right? Which will help us to build more intelligent assets, right? So definitely it's not an easy task to get this context out, because many of it is also institutional knowledge or tribal knowledge which stays in people's head and not really documented somewhere. And even if it's documented, it's not always up to date or always properly maintained, right? Now, has anyone here tried creating their own bots? Anyone? Okay. A lot of people have tried it. So what's been the most common problem in creating a bot? Context. The reason for that is all of these LLMs, ChatGPTs, and all that we try to use, they have been trained on a set level of information, right? That may not always be relevant to you, right? Let's say the same retail use case that I took, if that LLM doesn't even understand what a retail business is or what that customer does, the responses will always be fictional, right? It's like always having that overconfident friend who will give you any kind of answer you will ask, be it about sorcery, pottery, medieval knowledge, rocket science. It will give you an answer, and very confidently. You may even trust that, okay, the answer may be right, right? But most of the time, it will be fiction if there is no context behind that answer, right? So that's where these are some of the common challenges that we faced when we were solving this use case. Lack of a domain metadata, right? So all the metadata that we're capturing to build this context, how do you store it? Or more importantly, how do you collect all of this information from so many different variety of sources, right? So that is one. Second is you have so many different kinds of data, how they're related to each other. So the relationships are always missing, or it's like a tribal knowledge that is not documented somewhere, right? Which is also something that we had to capture. Then the coverage of the information, right? So we have a lot of information sitting in PDFs, PPTs that are presented out to a set of people, but the LLM is not really aware about it, right? So that is also something that we had to capture to build this context out, right? And the most important is to always keep this context up to date, because there is always something new going on in the institution, organization, new policies come up, new regulations come up. How do you keep this LLM up to date, right? So how do we build this context? So that is where I'll start with a high-level overview first, and Mansit will do the deeper dive from that point onwards. We talked about structured and unstructured data, right? Now, structured data is easy to handle, I would say, because we have been doing it for so many years and really well using traditional RDBMS systems. But when it comes to unstructured data, that's where the cracks start to appear, right? So if you have PPTs, PDFs, images, audio files, video files, right? So you have to convert all of that into a format that the LLMs can understand, right? So that's where we start going into text embeddings, text chunking, or using OCR to get insights out of the image that's been given, or start transcribing the audio or video information, right? Which gets stored and end of the day into either embeddings store, a vector DB, or will be used into the information retrieval process that we will use as part of the agentic system. Right? Now, to do a deeper dive under context, like I showed, there are 4 pillars. There is metadata, there is vectorization, there is knowledge graphs. I forgot the last one, but Mansit will do the deeper dive from that point onwards.
Okay. Okay. So surely metadata is important. Every data engineer would agree in this place here. But when we talk about metadata, what do we talk? We talk about like schema footprint, what is the data type, what is the data quality rule, what is the range of values a particular point of column or particular table should cover, what is the source system, what is the loading strategy. So metadata is not just that. It also covers the business glossary. What is the definition of the column? What is the purpose of the table? What domain does it belong to? Is it marketing? Is it loyalty program? Or what does it mean? And in case of unstructured data, that is like from documents, from presentations, the most important thing that we cannot like train our, so basically cannot vectorize all the information that is present, right? We have to understand the sentiment out of it. We have to summarize what the document is saying. So that becomes very important. Then another thing that helps in getting more context about a column is descriptive stats. You all might have tried using Kaggle, right? Kaggle competition. In Kaggle competition, when you go, you just don't see the sample data, but you also see few descriptive stats, like what the histogram of it, what is the range, what are the distinct values present. So that also becomes a very important field for context. Then one last but the most important again is governance. We don't want like certain people to have certain accesses. Even if we are vectorizing our documents, vectorizing our summaries, we have to make sure that certain information should not be exposed to certain people. So adding compliance tag, adding sensitivity label is very, very important. And this has been inspired by PayPal data contracts. It's an open source GitHub repository. Please do have a look and try to implement in your projects also if there is a way. But don't you think like all of this information is too much, right? So certain things from code we can definitely do, like schema footprint, descriptive stats, and probably some elements of governance. But still, again, business glossary is too much to fill in. So how did we solve for all of this is something we want to discuss. Okay, next slide. Yeah. So we made sure through metadata has to be enriched through our ingestion framework. So instead of a business user raising a request to a data engineer that I want to integrate this table, what we have done is through a UI, the business user can add data through a UI. So basically, we have all the connectors. Like for example, it can be a third-party connector, it can be an Azure SQL connector, it can be an API connector. So all of these are available, where a business user will go to a UI and register the data they want to do. So with basic information, like where the location of the file is, what data they want to load, and is there a transformation step that is available. Once that is done, there are few validation checks that that information needs to pass through. Once that is done, data is loaded and passed into the required format in a bronze layer. For like big tables, we go ahead with like delta lake formats, and for unstructured data documents, it should be converted into markdown or the textual format we can call. So once that is done, we calculate the descriptive stats out of it. What I mean by descriptive stats is the other one that we saw, like what is the min-max range, what are the distinct values, all that information are being calculated. Once this is done, a notification is sent to the user, and the user can go to the portal and enrich, add more business details to it, business glossary details. Why in two different steps? Reason is, we don't want business user to fill definitions for each and everything, like 11 columns, not 11 definitions. It becomes hectic, right? So what we have done is, using the descriptive stats, the things that have been calculated, there is a AI recommender, like through Azure Functions, you may put it. So through Azure Functions, we are using this descriptive stats, the metadata that has been collected through code, and asking the asking the business user to fill in. So AI suggestion will come, and based on that, the SME or the business user can review then and there, and sort of proceed for the next step. Okay, our metadata is very solid now. A lot of information covered. But it is still enough for the agent's context. Metadata is there. We can just directly vectorize the metadata. But certain questions will be like this from business users, where they will ask, how has been the loyalty program effectiveness for a particular region, like consider California. So right now, whatever context we have collected, it just gives definitions. It just gives like where the data is located and things like that. But once we start vectorizing it, the major problem that it has is it loses the URL, like where the data came from. It cannot find which field it belongs to, like certain information. And multiple hits from the same asset looks like separate results. We don't really know what's happening there. So what we have to do is vectorization with tagging when it comes to metadata especially. I know it's a little expensive to do this all the time, but this is something will be very essential while we are using our metadata. So idea is every embedding should carry a tag of the URL from where URI of your data set where it is present. If we are doing that, two things we are doing. One is it improves the explainability. Explainability in the sense like it will give you the site when the semantic search happens, it will give you the result with also the explainability of why this particular search result came, like from which data set or which asset it came from. And also, most importantly, you will have URIs present. Let's say if the user want to deep dive more, the URI will help to deep dive to the data set and get additional details there. So how do we do this? It's simple. It's the metadata information that we have, the JSON file, we flatten it, we make sure the key and value is stored, definitely, and chunks are created based on per field method, per field embedding method. So basically the embeddings that will be created will have one key attached to it. Once that key is attached, like for example, business definition. Business definition key will be attached to the business definition embedding. Once that is done, we also tag with the URI of the data set where it is coming from. And then observe everything to the PG vector DB, like, or Pinecone, like whatever you can call. So yeah, vectorization with tagging is great. But is it still enough? We have collected context from like unstructured data, structured data as well, and also vectorizing metadata with tagging. But is it still enough? I'll answer in the next slide. So when you call, like keep data set in one side, keep business in another side, the metadata that we have kept is more closer to the data. What column is the definition? What table purpose it is? What domain it belongs to? But we also need, because the questions that will be coming from the business will be from their perspective, from their business. Like for example, I want to see how has been my marketing ROI. I want to see how the customer demographics looks like. So the way we also have to make sure that business process documents, that are the docs, PPTs, needs to be there. With that, something that has been very effective that we saw is a knowledge graph out of it. So I'll move to the next slide. Yeah, in knowledge graph, what we have tried to do here is, let's say team, marketing team. What data products that marketing team has to go through? Consider customer 360 view. What dashboards that data product contains, list of data dashboards, and what KPIs one dashboard contain, what data set that is belong to. So whenever user asks the question, it first goes through the knowledge graph, subsets the data. Like for example, I'm a marketing guy. I will go and ask, I need a marketing spend ROI. This marketing keyword will go and sort of see like what is the area of coverage that needs to be there. So in that way, we subset the vector data set we are taking in. Instead of like traversing through the entire vector DB, we are traversing only a subsection of that information. In that way, our information becomes more directed and more correct. Great. But again, is it still enough? context from different sorts of data, vectorization metadata is done, knowledge graph is done. Is it still enough? It's not enough. Because agentic systems that we talk about is not deterministic. It is stochastic, or you can call probabilistic. So the more things that we do, of course, like it will improve 1%, 2%, 3%, but we may stop at like probably 99.99%. But every percentage, depending on the domain that we are dealing with, depending on the use case that we are dealing with, every percentage plays a role. So it is very, very important that we proceed like 1 step ahead, 2 step ahead to see like what can be done there. So putting it all together, we have all the data sources. We see like what is the right set of context that needs to be loaded from here. Then from our Omni ingester, it gets ingested. Metadata enrichment setup helps us add the metadata to all the data sets that we are doing. The compute layer helps us in parsing and conversion. Then all the context in the context service serving layer, we add the knowledge graph, the vector store, and the search service. It can be any search service that you can use. So and then access info. This is more critical, and that we can load it through our governance tool. It can be Azure Purview here, and all of this acts as a one layer that any agent can use, domain agents. Like for example, it's called customer agent. Now, like domain agent, like customer agent, there can be like multiple other agents. What we have seen in one of the other customers that we are working with, they have created MCP server for 111 domains. So in that way, you can create, using those agents like one by one, you can build on top of it and like unlock like more number of use cases from there. Yeah, lastly, I want to end this presentation with a very important note, that data engineers are the chef, and context is the secret sauce, and data engineers know what amount of secret sauce needs to be added to make the recipe really better. So yeah, like Satya Nadella said that SAS will be dead, but data engineering is something that is going to grow from here on. Yeah, that's all I have.